Okay, so when we graph these graphs, what's going to end up happening is when we sketch this graph out, at x equals negative at positive 4, maybe I'll do this in red. So this graph, when I graph it, at x equals positive 4, we get something called a vertical asymptote. Okay, now that line doesn't actually exist. I'm just drawing it in as a reference. And basically this graph is going to kind of go like this. Okay, there's a 0 at negative 3, okay, and it's going to kind of go like this, and it's going to curve down, something like that. Okay, and there's a vertical line, and this is going to be at x equals 4. Along that line, the graph tends towards, and it gets closer and closer to that line without actually touching it, because it can never actually equal that line. But as we get closer to that line, x is getting closer to 4, and what ends up happening is we end up dividing by really, really small numbers, which means that the calculation gets really, really big. Okay, and this is from the positive side, so from like 4.00001, you're dividing by a positive number, you get a positive, really big number. The other side actually is going down to a really, really big negative number, because as I get closer to 4, for example, 3.99999 minus 4 is negative. I'm dividing by negative numbers, so I'm going to get a really big, small number, but negative, so it's going to go really big negative downward. Okay, and it's just a line that we can't touch. It's called an asymptote. We get closer to that line, but we can't actually divide by that number. Okay, we can't divide by x4 minus 4, or we can't divide by 0. Now we're just going to focus on the vertical asymptote, the restricted value for x, but some of you may have noticed that something is happening along the y as well. There's actually what we call a horizontal asymptote. Now we'll leave that to later, but for now we're going to focus on the x, or the domain restrictions. So the same thing is happening over here. Okay, at x equals 3 and x equals negative 1, okay, at negative 1, we end up again with a line that we can't quite get to. Okay, and at positive 3, okay, when I draw these graphs in, okay, this graph tends to look like this. It's going to curve like that. Okay, it's got, now let me just think, I haven't drawn this for a while. So it's going to cross at here and at negative 5, somewhere around here. So it's going to look something like this. Okay, and we get a graph kind of going down like this. Okay, so again, notice that at the restricted values of negative 1, the graph can't actually touch it. Okay, we can't actually get there. Can't get there from the right hand side. It can't get there from the left hand side, because we're dividing by 0. And dividing by 0 can show up as this, what we call a vertical asymptote. Same thing here. When x is equal to 3, we're dividing by 0. Okay, so we can't actually get there. It wants to get there, but can't. It just bends away. And again, if you're wondering why one's going up and the other one's going down, it's because we're actually dividing by really, really small numbers in the denominator, which makes our calculation really big. It could be really big positive, or it could be really big negative going down this way. Okay, so that's why one's going up and one's going down. But the main idea, though, is that at the restriction, there's something going on the graph, and that something here is what we call a vertical asymptote. Okay, so what's happening at the graph? We are getting vertical asymptotes where we have restricted values. In other words, where we're dividing by 0. Okay.